Okay, in this video we're going to be talking about inscribed angles. So last time we did central angles coming from the center. Now we're going to do other types of inscribed angles. Okay, so just some vocab. A chord of a circle is a straight line segment whose endpoints both lie on the circle. So a chord, you can kind of think of a guitar string. Okay, a chord on a guitar string is going to end. Okay, so it's going to end and go through your circle. A secant is going to continue. So it's got arrows. So it's part of a chord, but it's going to keep going. So it hits 2 points, but it continues. Tangent, think touches. It touches the outside of your circle once, and then 99.9% of the time, it's going to have arrows and keep going. So tangent, think touches. Chord, think of a chord on a guitar, where it's going to end. And secant is like a chord, but it keeps going. Okay, so some of our rules. Now, it's not coming from the center of my circle. It's coming from the opposite side. So if it touches the opposite side of the circle, the arc that it opens up to, if I'm coming out to it, I times it by 2. If I'm coming into it, I divide it by 2. So if it touches the opposite side of the circle, the arc that it opens up to and connects to, you either double to come out, like you're getting fatter, or half it to come into your circle, getting skinny. Okay, our next rule. If they open up to the same arc, they're going to be the same degree. So if I take this angle and open him up and connect him, he opens up to that one. If I take this angle, they open up to the exact same arc. So if this is 20, that means I double them to come out, so this is 40. And then to come back in, I want to get skinny, so I half him. So this is going to be 20. So if they share the same arc, they're going to be the same measurement. Okay, anytime you have a four-sided figure in a circle, the opposite angles are supplementary. Okay, so anytime you see a four-sided figure anywhere, these angles will equal 180, and these angles will equal 180. Just like our normal quadrilaterals, opposite angles are supplementary. And our last rule, an angle that is inscribed in half of a circle or a semicircle is always a right angle. So if I take this angle and I open him up, he connects to this. Okay, that represents 180 degrees. Well, if I'm coming in, I would half 180 and get skinny, which would represent 90. So anytime you see a triangle in half of your circle connected to a diameter, there will always be a right angle. All right, so since this is touching the opposite side of my circle, the arc that it opens up to, if I'm coming out, I double it. So this is going to be 48. Okay. I bring him out to the arc it connects to. Okay, I'm actually going in this time, so I'm trying to get skinny, so I'm going to half it. So this is going to be 44. Okay, my next one, I know he opens up to this, and I don't have this. Okay, well I know 360 degrees is all the way around my circle, so if I take off that 90 and that 96, I have 174 left. And then I can half that to come into my A. So 87. Okay, so it looks like this A opens up to 56. So I'm going to half him to come in. So this is going to be 28. Once you find one, write it in, because it might help you later on to find another piece if you have multiple things missing. Okay, if I look at B, he opens up to 94, so I half him to come in. So B is 47. Anytime I see a triangle, I either work the triangle or work the fact that it's a right angle. Okay, so I know there's 180 degrees in a triangle, so I'm going to take off that 28 and that 47. And I get 105 left. So that means this little angle right here is 105. Which is vertical to C. Since it's vertical, they're going to be the same degree. So C is going to be 105. Okay, this one, you have to remember four-sided figures are supplementary. So I can find A because the opposite angles are supplementary. So 180 minus 98. A is going to be 82. Okay, the next thing is we're just going to double things out. So I need to figure out what angles open up to C. So if I look at C, I know 98 opens up to it, but if I connect it, I have too many things missing. So now let's see, I know 76, if I connect it, opens up to it. So I'm going to bring him out. So 76 times 2 gets me this whole thing to be 152. The problem is I don't want that 34 in there to get what I want left. So I'm going to subtract that 34 off to get C to be 118. All right, now B, let's figure out what angles open up to B. So it looks like 82, if I connect it, opens up to it, and it doesn't have multiple things missing. So I'm going to double 82 out and get 164, but I don't want that 34 again because I want what's left, which is going to be my B. So that's how I get 130. So you're kind of seeing which angles open up to it and then doubling them out. Okay, my next one, I know I might have to work a triangle again. So if I open up B and connect it, that 140 goes to him. So I'm just going to half him to come in because he's touching the opposite side of my circle. So he's 70. Okay, I'm going to work that triangle. So 180 minus 70 is 30. And that A opens up to that 30. So I'm going to double him to come out and get 60. Okay, this one, let's go ahead. I might have to work a triangle in here. Let's go ahead and open up A, because I just wanted to choose that one first. Okay, A opens up to a semicircle, which is 180. So I'm going to half him to come in, which is 90, which means this little guy is going to be 90 over here. Okay, I know I need to work that triangle at some point. So the only other thing in here is that 74. So I'm going to take that 74. So there's another route you could have gone. You could have gone the fact that it's a semicircle and then halved it in. I'm going to go this way, so I'm going to half this little guy in and get 37. And then I'm going to work my triangle. So 180 minus that 90 minus 37 will get me B, which is 53. I do not have parallel lines, so it is not 40. Okay, I do not have arrows showing parallel, so do not assume he is 40. Okay, you could have also worked the semicircle. So the fact that this was 180, do 180 minus 74 to get this, and then half it to come into that B. That's another route. Okay, so now I need to find C. Okay, so I could work my triangle on the other side. So 180 minus 40 minus 90 will get me 50, which will be him, which then opens up to that C. So I would double him to come out and get 100. All right, the measure of an angle is formed by a tangent, and a chord is half the measure of its intercepted arc. So it's going to be the same halving and doubling, okay? It's considered touching the opposite side. So if I take this angle and come out to the arc, I'm still going to times it by 2. If I take this arc and come into the angle, I'm still going to times it by a half or divide it by 2. It's going to work the same as touching the opposite side of your circle. It's just we're working with this tangent line and its chord, which is the other black line. Okay, so its angle, I'm coming out to its arc, so I'm going to double it. So 106 times 2 is 212. Okay, this next one has multiple routes we can go. I know 360 degrees is all the way around my circle, so I'm going to do 360 minus 224 to get my B and get 136, and then I'm going to half him to come in and get my A. Okay, you could have also halved this guy and came in, and then worked the fact that this was 180 degrees, and then doubled to come back out if you wanted to go that way. Okay, this next one is kind of a trick question. Last lesson we learned that if it comes from the center, it does not double to come out, it matches. So since this is 38, this is 38. Now I can use that 38. This is touching the opposite side of my circle, so now I can half him to come in. So 38 divided by 2, my A is going to be 19. Now that I have every part of the arc but one side, I've got all this, I want to find this. I'm going to do 360 minus those two things. and get 176, which will be my C. And B is touching the opposite side of its circle, so I'm going to half him to come in. So you just have to remember, if it comes from the center, it is the same. If it touches the opposite side, that's when we're halving and doubling.